Good morning, students. Myself, the Dr. Santosh Choudhury, Radial in Chemistry. Last class, we have to discuss all about the ether. That is, the chapter is closed. That is where we have discussed alcohol, phenol, and ether. Their method of preparation, properties, and some uses. And there is we will discuss some conversions. Okay, students, today we will discuss, we will start a new chapter, that is aldehyde ketone carboxylic acid, and this class number is 1. So today we will discuss what is aldehyde and ketone, functional group, and its nature, and the nomenclature, isomerism, and some method of preparation. Okay, so first come to what do you mean by aldehyde and ketone. Aldehyde and ketones a same class of compound, a class of carbonyl group compounds. The carbonyl group means the carbon bonded with oxygen. That is, carbonyl group is a bivalent functional group in which the carbon atom bonded with oxygen by double bond. That group is known as, this group is called carbonyl group. And this carbonyl group present both in aldehyde and ketone, and the aldehyde and ketone almost same character due to the presence of same function with carbonyl group. Next question is, what is aldehyde, what is ketone? So aldehyde means, you see, this is a carbonyl group. This carbonyl group is 2 valence, that is called bivalent. So when the valency of the carbonyl group, this is a carbonyl group, if one of the valency is satisfied by hydrogen atom, at least one, in some case both, then you can say it is aldehyde. That is C double bond O H, this is your aldehyde, and this may be H, this may be R. So the functional group is C double bond O H, or simply you can write CHO. And this is any alkyl group, we can say R CHO, that is called aldehyde, and the R may be H. But in case of a ketone, both the functional group, both the valency of the carbonyl group satisfied by same or different alkyl groups. So not with hydrogen, only with the alkyl group. Then you can say ketone, that is R, CO, R. This is called ketone. If it is H, aldehyde. If it is R, it is called ketone. That means a ketone minimum 3 carbon atoms. A ketone minimum 3 carbon atom. But an aldehyde minimum 1 carbon atom. This means only 1 carbon atom. If you take H here, this contains only 1 carbon atom. So this is your ketone, and in this ketone it contains 2 alkyl group. If the 2 alkyl group are same, then we can say it is a symmetrical ketone. In some cases, if the 2 alkyl group are different, suppose this is R, C, double O, R, this is called unsymmetrical ketone. Why is it called unsymmetrical? Because R is different from R. So ketone containing 2 alkyl group, and if the 2 alkyl group are same, then you can say it is a symmetrical ketone. If the difference, that's called unsymmetrical ketone. I will give some examples. Suppose you take the aldehyde examples of aldehyde. The example aldehyde are, what is the function group? R, CHO. So you see the aldehyde group always present in the terminal part of the carbon chain, means one at one end. So the examples are H, CHO, CS3, CHO, C6, H5, CHO. You see these are the functional group of aldehyde, and CS3, CH2, CHO. This is some example of aldehyde. Suppose you take the glucose. What is the formula of glucose? What is C6, H2R, O6? The structure of glucose is CHO, CHOH, 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 and CH2OH. And you see glucose contains aldehyde. So you can say glucose is a polyhydroxy, means more than one OH group. Polyhydroxy aldehyde. That's why it's called aldose. The glucose is called what? One type of aldose. You see, ald means aldehyde. Okay, these are the example of some aldehydes. And what about the ketones? And ketones, some example of ketones. You know, the ketone containing minimum 3 carbon atom. That is, the formula is RCOR. This is a non-terminal. What is non-terminal? The function group never lies in a terminal position. It always lies at a non-terminal, within a chain, not in terminal. Okay, the ketones, suppose your best example is CS3, CO, CS3, and this is known as acetone. You know, the acetone is generally used as a solvent, particularly your nail polish remover. Using the acetone to remove the nail polish from your nail, that's called acetone. Another example is CS3, CO, CH2, CS3. The ketone containing 4 number carbon atoms. And one group is methyl, another group is ethyl. And one group is methyl, another group is ethyl. Another is aromatic, that is C6, H5, CO, CS3. This is a aromatic ketone due to presence of this benzene ring. This is aromatic ketone due to presence of benzene ring. Can you say out of these which are symmetrical, which are unsymmetrical? And you see in acetone, this is CH3, this is CH3, both are same. So this is a one example of symmetrical ketone. But in this case, CH3, this side is C2H5, C2H5, this is called unsymmetrical. And this is also C6H5, this side CH3, this is also unsymmetrical. Are clear that aldehyde and ketones are the carbonyl group compounds? The carbonyl group means when the carbon atom bonded with oxygen by double bond and the carbon is bivalent. If one of the valency of the carbon group is satisfied by hydrogen, then you can say aldehyde. That's why aldehyde function group is CHO. And it is a terminal function group, always like the terminal position of the carbon chain or of the organic molecule. On the other hand, when the two valency of carbonyl group satisfied by two the same or different alkyl groups, then you can say it is a unsymmetric. Then you can say it is a ketone, and ketone are two types. One is symmetrical and is called unsymmetrical. And symmetrical ketone containing two same kinds of alkyl group, whereas unsymmetric ketone containing two different kinds of alkyl groups. And the aldehyde ketone possesses same functional group but have different character, little bit different character. That's why aldehyde and ketone are known as functional isomerism. Okay, students. Now you can also say the aldehyde ketone can also be derived from the alkanes. Suppose you take an alkane. Alkane is any saturated hydrocarbon, that is R CH2 CH3. If the hydrogen atom of the terminal carbon atom is replaced by oxygen, that is two hydrogen atom replaced by a oxygen atom. So this became CH3, two hydrogen is removed. You in that place you can place oxygen. It became R CH2 CHO. You remove these two hydrogen, it gives you what? Aldehyde. This is your aldehyde. That means it is an oxo derivative of alkane. What derivative? Oxo derivative of alkane. Similarly, if you remove this hydrogen gives you what? Aldehyde. And if you remove this hydrogen by the oxygen atom, this become R CO CH3. This is your ketone. So you can say aldehyde ketones are the oxo derivative of alkane. When the oxo derivative of terminal carbon is called aldehyde, and the oxo derivative of non-terminal carbon is called ketone. Okay, students? And this is all about your aldehyde and ketone. And next you come to the functional group. The functional group aldehyde is CHO and the functional group ketone is CO. Next come to nomenclature. Particularly aldehyde are CHO. Generally in common name, the common name derived from the source, that is, for example, HCHO. This is a least most aldehyde containing one carbon atom, least carbon atom. This is called formaldehyde. And this is CH3CHO. This is called acetaldehyde. CH3CH2 CHO. How many carbon? 3 carbon. This is called propionaldehyde. And this one, if you increase one more carbon atom, CH2, CH2, CHO. This is called butyl aldehyde. It's containing carbon atom. If you containing 5 carbon atom, that's called feraldehyde. And what about the IPEC name? In IPEC name, in IUPAC system, the name of the aldehyde, that is the alkane parent chain, the E can be replaced by, or the suffix E can be replaced by Al. This became alkanol. Methane, methanol. Ethane, ethanol. Propane, propanol. So if you say what is the name of this common name, formaldehyde, IP's name is formaldehyde. In formaldehyde contain, you see one carbon atom. The parent chain is your contain one carbon atom, methane. That became, this is called methanol. What about the acetaldehyde? You see acetaldehyde containing 2 carbon atom. We can say ethane. From ethane, we will remove E. That became, this is your ethanol. And what about this one? It contains 3 carbon atoms. 1, 2, 3. This is called propanol. What about this one? It contains 4. 1, 2, 3, 4. So this contains butanol. Suppose if you take a aromatic aldehyde C6H5CHO, this is known as benzaldehyde. This is also very common name also, that is IP name also, benzaldehyde, or you can write benzene carbaldehyde. Benzene carbaldehyde, because C6H5 benzene, CHO is carbaldehyde. Okay, this is about your name of the aldehydes in common system as well as some IPAC system. Let us give some a complex molecule to name the aldehydes, that is your CH3, CH, CH3, CH2, CH, CHO, CH3. So what is the function group with the aldehyde group there? And the carbon atom which possesses the aldehyde group, you must be numbered as 1. So this carbon atom is 1, 2, 3 is not longest. 1, 2, 3, 4, 5. Okay, so what is this compound? That is 2-methyl. You see, this is 2 carbon contain methyl, 4 as contain methyl, 2,4-dimethyl. The carbon chain contains 5 carbon atom. This is called pentanol. This is called pentanol. 2,4-dimethyl pentanol. Suppose I will give you CH3, CH double bond, CH, CHO. What is this compound? You see, this molecule contains double bond as well as CHO group, and CHO group is more priority than double bond. So 1, 2, 3, 4. 4 carbon, but 2 En means double bond, and contain second carbon, 2 number carbon atom, and 1 L. And this is very common name, is known as crotonaldehyde. Okay, students, we can name the aldehydes according to IPS name. Now come to the nomenclature of the ketones. In ketones, the ketone means R, CO, R, or generally the common name we can name this dialkyl ketone. For example, if you take CS3, CO, you know the ketone contains minimum 3 carbon atom. So CS3, CO, CS3, this is known as very common known as what? Acetone, or you can say dimethyl ketone. Why it's called dimethyl ketone? Because the acetone contain 2 methyl group, that's why you can say it is dimethyl ketone. Suppose if you take CS3, CO, CH2, CS3, you see this is ethyl group contain 2 carbon, methyl group. Ethyl, methyl ketone. Ethyl, methyl ketone. Suppose if you take CS3, CH2, CO, CH2, CS3, this is ethyl group, this is ethyl group. What do you say? This is called dimethyl ketone. If you take some aromatic compound, that is your, suppose you take benzene ring C6H5, CO, CS3, this is popularly known as acetophenone. You see acetone, acetone, acetophenone. Phenone means phenyl. Acetophenone. And out of these, some are symmetrical, some are unsymmetrical. Can you identify which was symmetrical and which is unsymmetrical? So this is your symmetrical, this is unsymmetrical. Why? We got 2 different groups. This is again symmetrical, this is again unsymmetrical ketones. And you see again this ketone is called methyl ketone because it contains a methyl ketone group. This is also called methyl ketone. Do you know what is methyl ketone? The molecule contains a methyl ketone group, means CH3. Is this methyl ketone? This is not a methyl ketone, this is a methyl ketone contains a CH3 CO group. This is also a methyl ketone. Okay. Next kind of what is the IUPAC name of the ketones? In IUPAC system, the ketones, that is the alkane, the E can be replaced by ONE. E can be replaced by what? ONE. That means this became, E can be replaced by ONE means this became alkanone. What? Alkanone. So what is the name of this one? It containing 3 carbon atoms. 1, 2, 3. What is its IUPAC name? The IUPAC name is propane. From propane it became propanone. This became what? Propanone. What is propanone? Because the molecule containing how many carbon atoms? 3 carbon atoms. That's called propanone. And what about this one? Contain 4 carbon atoms. 1, 2, 3, 4. That is called butanone. What is called? Butanone. That is buta NON to butane to ONE. That's called butanone 2. Why you write 2 there? Because the second carbon atom, 2 number carbon atom possesses the keto group. That is called oxo group. And this is what? How many carbon atoms there? 5 carbon atoms there. And this is called pentane 3-ONE. The pentane means 5 carbon atom and 3 number carbon containing 2, 3 number carbon atom containing oxygen or keto group. Pentanone. And what about the name of this one? Whether you can say it is what do you call it? It is called estophenone, or we can say this is carbon 1, this is 2, then 1 phenyl ethanol. 1 phenyl ethanol. Okay, student, these are the nomenclature, some ketones. Let us you take some complex molecule to name the ketones. Suppose CS3, C double bond O, CH, CS3, CH double bond, CH, CS3. This is a ketone. We have named in IPS system, and this one is a keto group is there at second carbon atom. So you are numbering this side to nearest to the ketone group 1, 2, 3, 4, 5, 6. And this is your substituents at carbon number 3. So you can say this is 3-methyl. 3-methyl. How many carbon atom? 6 carbon atom. We can say hex, because there is the presence of a double bond. That is hex 4En, 4En, and 2. This is called what? 3-methyl H4En 2-ONE. This is the name of this compound. We can name this compound as in your book. Okay. Next come to you talk something about the isomerism. In isomerism, the general formula of aldehyde ketone CnH2nO. The general formula of the aldehyde ketone CnH2nO means the number of hydrogen atom is 2 times that of the carbon atom. And aldehyde ketones can exhibit chain isomerism, position isomerism, and the position isomerism generates one by ketone, not by aldehyde, only by ketone. And it can exhibit the functional isomerism. The functional isomerism, that is the general formula of CnH2nO, it may be represent a aldehyde having a CHO group, it may represent a ketone having CO group, it may represent another functional isomerism is unsaturated aldehyde or ketone. Means this containing aldehyde unsaturated unsaturated alcohol. Unsaturated alcohol means the presence of carbon-carbon, double bond and a OH. Suppose I will take the general formula. Suppose I take a particular compound having formula C3H6O, and from this we can represent, that is that is CH3, CH2, CHO. This is called propanol, and we may represent this is CH3, CO, CH3. This is called propanol, and it may represent as also CH3 double bond CH2OH. Same formula. 1, 2, 3, 3 carbon atoms. Hydrogen is 2, 1, 3, 5, 6, and 1 oxygen. And this is called allyl alcohol. We can say prop 2En1. Okay, students, the same molecular formula having three different compound having different functional group. This containing a CHO group, this containing CO group, this aldehyde group, this is ketone group, and this is called, you can say, enol group. Means En means double bond OH. That is unsaturated alcohol. Okay, and now come to the ketone source. Some of that is ketone source, the metamerism. That is the metamerism shown by ketone having carbon atoms more than 5, more than, you can say, 4. What is metamerism? You see, the keto group is a bivalent, and the bivalent keto group have different alkyl groups in different structure of the ketone. That's called metamerism. For example, I will take a ketone like C5H10O. This is a general formula of a ketone, and I can draw so many isomerism. One is called CH3, CH2, CH2, CO, CH3. One structure. Another structure is CH3, CH2, CO, CH2, CH3. You see, this is a propyl group and this is a ethyl group. Two different structure, two different alkyl groups in the sides of the ketones. And another one is CH3, CH, CH3, CO, CH3. You see another type of alkyl group. That is, different structure possesses different alkyl group, same side of the keto group. So we can say this is one isomerism, this is isomerism, this is isomerism. You can say this may be a chain or position isomerism, but these are not called chain or position isomerism. These are called what? Metamerism. And these are called one metamer. The metamerism means the isomers are called what? Metamer. So what is the name of this compound? This one is, you can say, pentane. How much? 2-ONE. And this is pentane 3ONE. 3 means 1, 2, 3. This one is 1, 2, 3. You can say this is 3 methyl butane 2ONE. You see the same molecular formula but with different type of ketones having same functional group is same. But different name means different structures. Different structure means different isomers. These isomers are known as what? Metamerism. Or these isomers are called metamer, and these are called, this process is called metamerism. Okay, students. So many isomers are there, and aldehyde ketone can also show the that is called tautomerism, and in tautomerism in higher classes the tautomerism two form, one is called keto form and is called inormal. Everything there. Okay, next come to the nature of the functional group. Means what type of bonding? So students, both aldehyde and ketone containing carbonyl group. Aldehyde or ketone is containing the carbonyl group. This is what group? Carbonyl. So this carbonyl group, the carbon atom possesses sigma bond, and the double bond, one of the double bond is pi bond. This is sigma bond, this is sigma bond. And as the carbon atom possesses one pi bond and 3 sigma bond, so you can say this carbon atom undergoes the state of sp2 hybridization. If the carbon atom undergoes sp2 hybridization, so it has a structure that is called trigonal planar structure. If it is trigonal planar structure, the bond angle should be 120 degree. What is trigonal planar structure? That is C, this is called trigonal planar structure, and this is your pi bond oxygen. In carbonyl group, oxygen is more electronegative than carbon. So the carbon double bond is polar. Polar means there is small charge separation due to the more electronegativity. The pi electron will come to this side. This possesses fractional negative charge. This possesses fractional what charge? Positive charge. And what about the bond angles? You know, due to triangular bond angle 120, but this angle is not 120. This is little bit more due to the repulsion between this electron cloud and this electron. This is 121. This angle also 121, but this angle is 118 degree. Okay, the bond angle is not exactly 120, but less than 120, someone more than 120 due to the repulsion. We have a pi electron cloud and this electron cloud, this electron repel to each other. When they repel to each other, they apart little bit apart from one another. That's why the bond angle is what increases. Okay, and how does the carbonyl group different from alkene? Alkene means alkene contain carbon double bond, but carbonyl contain carbon oxygen double bond. Here sp2 hydration, here is sp2 hydration, but this is non-polar, this is your polar, and both are shows addition reaction, and this shows electrophilic addition reaction ADE, but this shows nucleophilic addition reaction. As these are non-polar, the melting point boiling point of such compound is low, but melting point boiling point of such compound is more. So this is some difference between alkene and carbonyl group. Alkene possesses carbon double bond, and carbonyl group and carbon oxygen bond. The difference is there. Okay, this is allowed to the structure or nature of the function group. Actually, carbonyl group is a polar in nature due to difference in electronegativity between carbon and oxygen. Okay, students, this is the allowed for some introduction to aldehyde ketone. And in introduction, you know what is aldehyde group, what is keto group, and the structure of carbonyl group, nomenclature. So the carbonyl group is polar in nature, and carbon atom possesses what? Partially positive charge, and oxygen atom possesses partially negative charge. Next come to method of preparation. The aldehyde ketone can be prepared almost same method of preparation from same compound. So the method of preparation of aldehyde and ketone almost same. The aldehyde ketone we can synthesize from alcohol, carboxylic acid, alkane nitriles, acid chloride, ester, alkyne, alkene. So from these compounds, that is, we can convert alcohol to aldehyde or ketone, which I will write in this way. Alcohol convert to aldehyde ketone, carboxylic acid convert to aldehyde ketone, alkane nitriles means what is that one? RCN can convert to aldehyde and ketone, and acid chloride can convert to aldehyde ketone, ester can be convert to aldehyde ketone, and alkyne can convert to aldehyde or ketone, and alkene can also be convert to aldehyde and ketone. Means we can convert this compound, this class of organic compound, that is alcohol, carboxylic acid, acid chloride, ester, alkene nitriles, alkyne, alkene, all are get converted into what? Either alcohol or either the aldehyde or ketone. And we have already seen the alcohol, how the alcohol get converted into aldehyde and ketones. Okay, students, let us you study the preparation of aldehyde ketone from alcohol. That is one from alcohol. You know alcohols, primary alcohol, secondary alcohol. From alcohol, the aldehyde ketone can be prepared by two methods. One is called oxidation method and is called dehydrogenation. Oxidation method, use some oxidizing agent, and the oxidizing agent is your PCC or PDC or Collins reagent or what? Jones reagent. If you use any other reagents other than this, the alcohol first oxidized to a aldehyde, and the aldehyde further oxidized to what? Carboxylic acid. The final product is you will get a carboxylic acid. To stop the oxidation at first step, means alcohol convert to aldehyde, we are using very specific reagent, that is PCC, PDC, Collins reagent, Jones reagent, or you can also use CS3, CO4 lead tetraacetate, and you can also use MnO2, very specific reagent, oxidizing agent, MnO2. And mind it, these reagents what used not affected to double bond. Not affected to the double bond. The alcohol, if the alcohol contains a carbon and double bond, when treated with oxidizing agent, then the alcoholic group will get oxidized, not the double bond. If you use other oxidizing agent like acidified potassium dichromate, acidic potassium permanganate, then they can oxidize both the double bond as well as the alcoholic group. Okay. So students, so let us see how the aldehyde ketone can be prepared from alcohol by oxidation method. So by oxidation method, and oxidation method, your oxidizing agent is your PCC or PDC or what is Collins reagent or what you call Jones reagent. What is PCC? PCC means pyridinium chlorochromate. Mind you, these are all are the compound of oxide of the chromium having oxidation state +6. So pyridinium chlorochromate. This is pyridine, you know, heterocyclic compound. This is called pyridine. This is called pyrrole. Pyrrole to pyridine. So the molecular formula is C5H5NH plus CrO4Cl minus. This is called PCC, pyridinium chlorochromate. If you say PDC, PDC means pyridinium dichromate. But this one, that is C5H5NH plus whole twice Cr2O7 in glacial acetic acid. Similarly, Jones reagent means chromic acid. What is it? Chromic acid. Chromic acid means that is CrO4 plus acetic acid in a non-polar solvent CH2Cl2. That is DCM, dichloromethane. So Jones reagent is your what is called, that is CrO4, that is another H3 CrO4 H2 CrO4 in glacial acetic acid and what is dichloromethane. And these reagent, these oxidizing reagent are oxidize the primary alcohol, that is CH2OH. This is your primary alcohol when treated with PCC. This is oxidized to an aldehyde. That means it first oxidized to CHOH, and this is another oxide. It get lost molecule of water, and this became CH. That is, the primary alcoholic group is oxidized to what? Aldehyde. If it is secondary alcohol, this is your what group? CHOH group means secondary alcohol. When treated with PCC, it gives you OH. These compounds are unstable and we get lost molecular water. This became a ketone. That is, the primary alcoholic group oxidized to aldehyde and secondary alcoholic group oxidized to a ketone. So, we can prepare the aldehyde ketone from alcohol. The primary alcohol oxidized to give an aldehyde and secondary alcohol gives a ketone. Let us see some examples. Suppose if you take a primary alcohol RCH2OH, this is your primary alcohol, and this is treated with the oxidizing agent like PCC. This group is oxidized directly, it gives CHO. Mind you, this cannot further oxidize to carbonylic acid, because the PCC is such a reagent which can stop the further oxidation of aldehyde to carbonylic acid. This is your aldehyde. Suppose if you take CH3CH2OH, what will happen? This group, this is your ethanol, will oxidize what? With the oxidation with PCC, can you write what product will get? What product? This group, CH2OH group will convert to CHO. This became CH3, CHO, and this is called your ethanol. Suppose you take benzyl alcohol, that is C6H5CH2OH. This is called benzyl alcohol. This is an oxidation with PCC. Mind it, this is not affected double bond. Double bond contain a benzene ring. It gives you C6H5CHO. This is your benzaldehyde. Suppose if you take allyl alcohol. Suppose I will take allyl alcohol. That is CH2 double bond CH2OH, and oxidize not with this one. This is very specific. This oxidized by MnO2. Very specific oxidizing agent which can oxidize the allylic alcohol to aldehyde. So this gives you CH2 double bond CHO. This is your crotonaldehyde. Okay, students, these are the oxidation of primary alcohol to an aldehyde. And what about the secondary alcohols? If you take a secondary alcohol, so this is your RCHROH. This is your secondary alcohol. The secondary alcohol oxidized with PCC, means this secondary alcoholic group get oxidized to ketone that became RRCOO. This is your ketone. Suppose you take propanol 2. This is your propane 2OL, what you call isopropyl alcohol, and this is your secondary alcoholic group. CHOH, these are the CHOH. The second alcoholic group, an oxidation, that is CS3CO. This became what group? CO group, CO, CS3. You can write in this way or you can write in this way also. This is your acetone. Okay, students, these are the method of preparation of aldehyde ketone from alcohol. One method is your what method it is? It is the oxidation method. And another method, you know, I have already taught in your alcohol chapter dehydrogenation. And the second method is called dehydrogenation. Dehydrogenation means loss of H2O molecule. That is, alcohol lost a molecule of hydrogen. How the loss of hydrogen get lost? By you take such a metal which can remove the hydrogen from this molecule, such as copper. Because the copper metal very strong affinity towards hydrogen. That's why the molecule get lost. Not at ordinary condition, at about 300 degrees C. That's why if you take primary alcohol, suppose this primary RCH2OH, this is your primary alcohol. When this primary alcohol pass into red hot copper at 300 degrees C, this get lost molecule of hydrogen. This bond come to here. What will happen? RCHO plus H2. This is your aldehyde. But you see this group, that it means RCH2OH group became what group? CHO group. Just take one oxidation. In that case, oxidation additional hydrogen, but in this case, removal of hydrogen. Suppose you take CS3, CH2OH and pass over red hot copper at 300 degrees C. What will happen? This group gets converted into CS3, CH. This is called ethanol, and this is ethanol. Suppose you take benzyl alcohol, that is your C6H5CH2OH, and passed over a red hot copper at 300 degrees C. So this group is converted to give C6H5CHO. This is called benzaldehyde. So what happens when benzyl alcohol pass over red hot copper at 300 degrees C? Means the benzyl alcohol dehydrogenate to give your benzaldehyde. Similarly, if you take a secondary alcohol, For the second alcohol, that is RCRH OH. This is your CHOH group. This is your secondary alcohol. When the secondary alcohol pass over red hot copper at 300 degrees C, it get lost molecule of hydrogen. In this hydrogen combined together, this became a ketone. What will happen? That is R C double bond O R plus H2. You will convert this second alcoholic group to ketone. Suppose you take propanol 2. And pass over red hot copper at 300 degrees C, this get lost molecule of hydrogen. So it became CS3 C double bond O. Yes, this is your propanol. Okay, students, these are the method of preparation of aldehyde ketone from from alcohols. The alcohol get converted into the aldehyde or ketone by oxidation or dehydrogenation. The primary alcohol gives you aldehyde and secondary alcohol gives you ketone. Okay, student, this much today. And today class will discuss the what is aldehyde, what is ketone, and what functional group is there in aldehyde ketone, and the nomenclature and some isomerism and nature of the carbonyl group. The carbonyl group is polar in nature because the carbon atom bonded with oxygen, more electronegativity oxygen atom. As a result, the carbon atom possesses partially positive charge and oxygen atom partially negative charge. And you discuss the method of preparation of aldehyde and ketone. The aldehyde and ketone can be synthesized from alcohol, carboxylic acid, alkane nitriles, ester, alkyne, alkane, alkene. From this, all these compounds can converted into the alcohol, converted into the what? Aldehyde and ketone. And we will discuss the primary alcohol and secondary alcohol get oxidized to give corresponding aldehyde and ketone by using a very specific reagent. The specific reagents are what? PCC, pyridinium chlorochromate, PDC, pyridinium dichromate, Jones reagent, Collins reagent, manganese dioxide. These are the reagents, okay, and which can convert the primary alcohol to an aldehyde and secondary alcohol to a what? Ketone. And you are not using the other oxidizing agent like acidified potassium dichromate or acidified potassium permanganate because this reagent can oxidize the primary alcohol, first oxidized aldehyde, which further oxidized to a what? Carboxylic acid. So when you start with a primary alcohol treated with oxidizing agent like acidified potassium dichromate or potassium permanganate, finally you get only carboxylic acid, will not get a aldehyde. To check the oxidation, we are using some specific oxidizing agent as your PCC, PDC, Collins reagent, Jones reagent. These reagents these are oxidizing agent, all are the compound of chromium having oxidation state +6. Okay, students, and the alcohol, the primary alcohol, secondary alcohol converted to corresponding aldehyde by dehydrogenation means loss of hydrogen. When the primary alcohol passed over red hot copper to given corresponding aldehyde by losing molecule of hydrogen. And secondary alcohol when passed over red hot copper at 300 degrees C, it is corresponding ketone. Okay, students, thank you. This was